A very good noon to one and all. And now, in this lecture, we will be discussing about the alignment tests on milling machine. So, previously, in the previous lecture, we have discussed about the alignment tests on lathe machine, and now in this lecture, we will be discussing about the alignment tests on milling machine. Okay, so in this milling machine also we have some 8 tests are there. So each test we have some instruments. Each test we have instruments and procedure and one diagram. Okay, so I hope you will be clearly understand about by completion of this lecture about the alignment tests on milling machine. So first step is flatness of work table. So in this test we consider it consists of the test conducted in longitudinal direction as well as in transverse direction. Okay, so flatness test of work table is conducted in longitudinal direction and in transverse direction. So for this test we have to take the instruments like spirit level. So only spirit level is the instrument in this test. The test name is flatness of work table, we have to check. Okay, so first step is flatness of work table in longitudinal direction, in transverse direction. So and the measuring instruments are the spirit level. Okay, and the procedure is a spirit level is placed directly on the table at points of about 25 to 30 centimeter apart at A, B, C for longitudinal tests and D, E, F for transverse test. Okay. So the procedure is a spirit level is placed directly on the table at points of about 25 to 30 centimeter apart at A, B, C for the longitudinal tests and D, E, F for the transverse test. Then at the A, B, C, D, E, F at the points the readings are noted. Okay, so by this we can check the flatness of work table. Okay, so once again I am telling the procedure. So the procedure is a spirit level is placed directly on the table at points about 25 to 30 centimeter apart at A, B, C for the longitudinal tests and D, E, F for the transverse test. Okay, so then the readings are noted at that points. So by this the permissible error for this both the directions in longitudinal and in transverse direction is plus or minus 0.04 mm. Okay, so this is the first step, and the next one is next second test is parallelism of the work table surface to the main spindle. Parallelism of the work table surface to the main spindle. So for this the measuring instruments are dial indicator and test mandrel with 30 mm long and spirit level. So these three instruments are used for this test. So dial indicator, test mandrel and spirit level. So this test mandrel is the 300 mm long, and the procedure is the table is adjusted in horizontal plane by a spirit level and is then set in its mean position longitudinally. Okay, so and the mandrel is fixed in the spindle taper. A dial gauge is set on the machine table, and the feeler it is adjusted to touch the lower surface of the mandrel. Okay, and the dial gauge readings at A and B are observed, the stand of the dial gauge being moved while the machine table remains stationary. Okay, so this is the procedure for this test, and the permissible error is point not to mm. Okay, so I hope everyone understand this step. So here the procedure is the table is adjusted in horizontal plane by a spirit level and is then set in its mean position longitudinally. The mandrel is fixed in the spindle tapper. A dial gauge is set on the machine table, and the dial gauge readings at A and B are observed. The stand of the dial gauge being moved while the machine table remains stationary, and the permissible error is a point not to mm. Okay, and third test is parallelism of the clamping surface of the work table in its longitudinal motion. Parallelism of the clamping surface of the work table in its longitudinal motion. So for this, the instruments used are dial gauge and straight edge. Okay, dial gauge and straight edge. So the procedure is a dial gauge is fixed to the spindle, and the dial gauge spindle is adjusted to touch the table surface, and the table is moved in longitudinal direction, and the readings are noted. If the table surface is uneven, it is necessary to place a straight edge on its surface, and the dial gauge feeler is made to rest on the top surface of the straight edge. Okay, by this the permissible error is point not to up to 500 length of the traverse motion, and point not 3 up to 1000 and point not 4 above 1000 length of traverse. Okay, so this is the third test in this alignment test on milling machine. And coming to the fourth step is parallelism of the cross movement of the work table to the main spindle. Parallelism of the transverse movement, cross movement of the work table to the main spindle. So in this step we have to observe in vertical plane, in horizontal plane also. So for this the instruments used are dial gauge and test mandrel with the taper shank. Okay, so dial gauge and test mandrel with the taper shank. So the procedure is here the work table is set in its mean position, and the mandrel is held in the spindle. A dial gauge is fixed to the table and it is adjusted so that its spindle touches the surface of the mandrel. Okay, and the table is moved crosswise, and the error is measured in the vertical plane and also in the horizontal plane. Okay, so this is the procedure, and the permissible error is point not to for the overall traverse movement of the work table. Okay, so this is the fourth step. And coming to the fifth test is true running of internal taper of the main spindle. True running of the internal taper of the main spindle. True running of internal taper of the main spindle. So the instruments used are 300 long test mandrel and dial gauge. Test mandrel and dial gauge. So the procedure is the test mandrel with its taper shank is held in the main spindle. Okay, the test mandrel with its taper shank is held in the main spindle, and the dial gauge is kept scanning the periphery of the mandrel, and the spindle is rotated, and dial gauge readings are noted at different points at A and B as shown in this figure. So the permissible error at position A, 0.01 mm, and at position B, 0.02 mm. These are permissible errors. Okay, so in this uh, machine tool alignment tests, so we are continuing the sixth step in the milling. So sixth step or test is squareness of the central slot of a work table with the main spindle. Squareness of the center T slot of work table with the main spindle. So here the instruments used are dial gauge and special bracket. So dial gauge and special bracket. Okay. So observe this lecture very clearly. So observe in with keen attention. Then you will get the easy information about these alignment tests. So each test we are having the instruments and procedure and permissible error and one small diagram. Okay, so now coming to the sixth test, instruments are dial gauge and special bracket, and the procedure is to check the perpendicularity of the locating slot and the axis of the main spindle. To check the perpendicularity of the locating slot and the axis of the main spindle. So the table should be arranged in the middle position of its longitudinal movement, and a bracket with a tenon at least 150 mm long inserted in the locating slot as shown in this figure. Okay, and a dial gauge should be fixed in the spindle tapper, the feeler being adjusted to touch the vertical face of the bracket. And observe the reading on the dial gauge when the bracket is near one end of the table, and the swing over the dial gauge and move the bracket so that the corresponding readings can be taken near the other end of the table. And the permissible error is 0.025 mm in 300 mm length. Okay, so I hope everyone understand this sixth test. And next seventh test is parallelism of the T slot with the longitudinal movement of the table. Parallelism of the T slot with the longitudinal movement of the table. So in this milling machine, we have to test the parallelism of the T slot with the longitudinal movement of the table. So the instruments used are dial gauge and special bracket. Dial gauge and special bracket. So the procedure is the general parallelism of the T slot with the longitudinal movement of the table is checked by using 150 mm long bracket having a tenon which enters the slot. Okay, and the dial gauge is fixed to the spindle tapper and adjusted so that its feeder touches the upper surface of the bracket, and the table is then moved longitudinally while the bracket is held stationary by the hand of the operator, and the dial gauge deviations from the parallelism are noted. Okay, and this the permissible error is 0.0125 mm in 300 mm long. Okay, so I hope everyone understand this seventh step also. And last step, which is eighth test, it is the parallelism between the main spindle and guiding surface of the overhanging arm. We have to test this alignment. So the instruments used are dial gauge and test mandrel. Dial gauge and test mandrel. So the procedure is the overhanging arm is clamped in its extreme ended position, and the dial gauge is fixed to the arbor support, and the feeler of dial gauge is adjusted to touch the top or right of the test mandrel. Okay, and the arbor support can then be moved along the overhanging arm, and the deviations from the parallelism observed on the dial indicator. Okay, so this is the procedure for checking the overarm to the cutter spindle. So parallelism between the main spindle and guiding surface of overhanging arm. Okay, so I hope everyone understand these 8 steps. Those are alignment tests on milling machine. Okay, so please read well, stay home, and stay safe. Thank you. Bye.